Thank you for joining us. The latest in the Yugabyte EMEA technical roundtable discussions. And this afternoon, our topic is SQL, old SQL, new SQL, distributed SQL, as I put it. What's the difference and why would I care? And to talk about that this afternoon, I have an excellent panel, as I think I always do have. I have Frank Pachot from Yugabyte. I have David Walker also from Yugabyte, and an old chum, Andy McCann, now with an organization called Intuitor in the UK. But I'm not going to introduce you. I'm going to ask you all to introduce yourselves. Frank, can I ask you to go first?
Yeah, sure. Cool. Hi, everybody. So I'm developer advocate at Yugabyte for 2 years. And before, I've always been working with databases, mostly SQL databases in consulting.
Thank you. David?
Hi, I'm David Walker. I'm the field CTO for EMEA, so I look after the technical team here. And my background is been almost entirely in databases too, starting with Oracle back in the dark ages and moving forward from there with all sorts of database technologies.
Andy.
Hi, yeah, it's Andy McCann. Recently joined Intuitor as data engineering director. I think like everybody else, my background's been in data. Worked for a few vendors, been on the customer side as well, so I've seen both sides of the fence.
Yeah, we'll come back to some of those, hopefully some of those experiences in lots of different places. And David, I think age before beauty. I think I'm going to ask you first, and I'm going to ask you a question. Is when did you first meet SQL? What were you doing? Why?
I was at my very first job. Well, actually, I was at university when we had Ingress as a database. And then my very first job, which is where I got serious, I got a whole bunch of disks for Oracle 4 on floppy disks, and I stuck them into an IBM 6150 and figured it out from there, which makes it really ancient history. And it took about 20 floppy disks to put it in there, and it was the student record system, which kept track of students' grants, and it was considered highly innovative at the time. But
why did they feel the need to use SQL for that? Back in 1980 something, it must have been.
Yeah, 1980. Why did they feel the need to see the government had actually given a grant for innovation into new technologies to store databases, and had given a place called Further Education Management Institute a grant to actually come up with a new way of managing student records. And so they thought they'd go with this really modern technology and try it out, see if it was any better. So lots of interesting old things.
So it was about innovation, really, and in fact, it was like SQL didn't force its way onto that scene, but it succeeded when it was introduced by a grant.
Yeah, well, yeah. What was interesting actually is we had to build this thing and get it all working, but very quickly it moved from the student record management system into the classroom environment because we had an Oracle database there. Other people wanted to use it. So actually very quickly the students were using it as well. There was some demand for this type of thing, which is quite interesting. And it was a need to have new systems which would bring things together quickly. And people latched onto it very quickly in that environment.
Because, I mean, my experience was that the reason for the early success was that the relational model, it just made thinking about and working with data so much easier. And then the language, which was designed for dealing with data, unlike programming languages before then, you were kind of like more clunky interface with the data. I think, I'm going to...
Sorry, I was just going to say, select star from a table. It tells you what you're going to do and join it with something else. So especially,
just made it so much easier.
It's almost
my experience at the same time. Andy, I'm going to go to the other end of the spectrum here, because not only you don't have grey hair, you have hair. So that puts you right at the top at the other end.
Yeah, I'm older than I look there. That's what you need to remember. So mine was randomly. Mine was actually also as part of being at university. So mine's the early 90s. And the IT degree I did, they had placement year, which was quite a common thing at the time. And we touched on databases a little bit and a bit of data modeling during the first 2 years. In the third year, we did the placement year. And at a bank, at TSB at the time, up in Manchester, I stumbled on a thing called Teradata, which I found quite interesting. I kind of got it and enjoyed it. And I've kind of been doing that ever since, really. So I've always been in this space. I think it's fair to say.
Look, I want to explore that more, Andy, because I think particularly for Yugabyte, where David and Frank and I are right now, it's all about operational. Indeed, my introduction, like David's, was operational systems, but SQL's got a strong track record in analytics, starting Teradata being one of the forerunners of that. So I'm going to come back to you and bounce about this. How does this same language work for operational, transactional stuff, but also for really big, hairy queries, which I remember you and I, particularly at Netezza days, there was some amazing queries run there. But before we get back to that, Frank, you want to give us, where did you first meet SQL?
I was on an Oracle database during university and during a university internship. So learning SQL, but not only to run queries, was the time where all the application was written in PL/SQL in some stored procedures or in forms or reports. So yeah,
wow,
SQL, relational database, normal forms, applying everything I've learned from the university, and then starting to forget about it and starting to denormalize and see the real life of databases.
That denormalize, that you said the D word. I think I actually want to explore that one as well a bit. But I'll just finish the intros with me. It just proves I'm a lot older than you guys, because when I first met SQL, I was already in the world of work. I wasn't, on placement or undergraduate. I was already in the world of work, and I joined Oracle in mid-80s, and that's when I sat down in a classroom to learn SQL. And a few months later, I was billing out to customers as an expert in SQL. But let's brush over that. And I'm going to, unlike you guys, I now probably have written my last line of SQL, at least that anybody would pay me for. And I think that was the last time was I think for some PL SQL for the back end for a Java application that some engineers at Oracle were building, and that was at least 15 years ago. So but I have been watching what you guys have been up to ever since, so I know where I am in the world of SQL. And that's, if you like, we started from that, where we all first met it. And what came out of that for me was, really interestingly, operational and analytics emerges straight away as there's two threads going on here. And also, Frank, you hinted at it, you didn't say explicitly, this difference between the kind of the formal relational modeling normalization. I'm not going to ask David, can he define fifth normal form, because I'm sure he can. And that would be, I'm not going to give him the opportunity to do that. But there was going on, was like you said, Frank, we all learned our third normal form, and we all knew how to do data modeling, in normalized data modeling. And then the first thing you did when you implemented a database was you start denormalizing in order to make it run at a reasonable speed. So I'm going to come back to you, Frank, since you introduced that, and we'll go with that denormalize. How much was denormalization like a compromise? Oh, relational's too theoretical, it doesn't work anyway, so you have to do this denormalization to make it work. And how much is it, well, no, you draw an ideal picture and then you tune that picture for the use cases, for the workload that you're trying to address. I mean, that's the way I always thought of it. Does that make sense to you, Frank?
Yeah, but what I've seen was that usually people were talking about denormalization, and it was kind of premature optimization. You don't have a problem, but you think you will have a problem with joins, and then you denormalize, and that's probably not a good idea. I've seen a lot of people talking about denormalizing when they didn't really need to. Of course, there are cases where you need, and in data warehouse where it can be okay, but it was already that time where people thought that joins don't scale, and we will probably talk about it later.
So in other words, people like jump too far the other way too quickly. Is you don't know you've got a performance problem until you've run the query. Yeah, it may run perfectly well. Yeah.
Before having any problem, or before looking at the real problems, the real size of data or of queries, people started to denormalize as a solution to everything.
Right. So starting, you mean you're saying it's a tool in the toolbox for making the application run as fast as you need. It's not a it's not a predefined stage in the database design.
Yeah, because of the side effects. If you denormalize, then you duplicate data, and then if you have to update it, you need to keep it consistent.
I think Diane, in the early days, some of those compromises were probably because of a little bit because of performance, but I also think occasionally, maybe in my experience, what's good for some people with the normal form models was it could be quite complicated for the business user to actually understand data, pull it together. So maybe some of the performance challenges come from them doing things wrong because they didn't understand how to navigate the model. So certainly my early days in Teradata and the likes, a lot of the physical database design, shall we call it, you'd have your logical model, which would work beautifully, but then you did occasionally have to simplify it for users. You occasionally, with the high volumes at the time, because of limitations of technology, you did have to do it for performance from time to time as well. So I think there's a mix there, really. But yeah, I completely agree with Frank, is the less copies, the less hops we've got in getting the data from the source through to the end user, the better.
Because that was, that was always when I first met, the relational theory, the whole point of it was then you only need to store every piece of data once, not because disks are expensive, although compared to now, storage was clearly massively more expensive, but it was because it was simpler and more, quote, logical. You could relate to the real world. Yeah. David.
Yeah, I think so. Storage was expensive, right, as well. There's things like that. But again, it's the nirvana, and we're still trying to do that today. Because especially in the cloud world, the more silos we've got, the more hops we've got between, the more challenging we've got integrating it, the more challenging we've got with governance and security and all these types of things. So it's always been there, even as technology speeds up, and we do potentially have the ability to use less copies, which certainly been something I've been focused on the last few years, trying to reduce those data silos.
Yeah, I want to. We'll pick up on that, because that's part of this, the whole sort of operational, not just the bifurcation of operational and analytic, but actually what's the connection between the two, the data lifecycle that takes one to the other. And again, that's something for a little later, I think, in the story. I'm going to go back to David and talk about we've introduced with denormalization the subject of performance and the trade-offs you might have to make. What's your view on denormalization back in the old days and now, and is it different? Has the world changed around?
Yeah, as Frank said, denormalization is one of those things which was probably early optimization. But you also have to think about the tools that we were using. Building databases, I remember spending hours pouring in front of Oracle Designer, doing models, logical uppercase and lowercase models, and implementing them, and all of the things that went to those words. And so, the cost of doing the model was sometimes outweighed the development cost, which is why people were tempted to optimize early. Nowadays, there's a couple of things which are changing that need as well. First of all, I would say that there's better abstraction between the database and the user experience. So if you're doing stuff at the front end, you don't see early tools that reported on the database, the user was expected to have some understanding of the SQL model. And so you literally, if you were using business objects or a tool like that, you had to understand the model, and these things looked complicated, and business users, it was meant to be business users, but it was difficult for them. That abstraction's cleared out these days. Your tools like Tableau and things make it really easy. And the other thing which I think's changed for me is the use of JSON in objects as well. So that some of the things that would be at the far end of models, the table's rarely updated, but with some key attributes with it, are now stored much closer to the main table. So I think people's temptation is to use some of that, that type of data in JSON objects rather than push it out to the far reaches of a fifth normal form model. So I think the technology add to that computing power and storage costs, and I think we've moved a long way in terms of how we understand and manipulate the data, and the power that's come with that.
So it sounds like basically we had this first early upsurge in use of SQL because it just seemed a more natural way to work with data. You all talked about your early experiences being sort of diving in, and there was swift adoption, and that's how I remember it. And the next 10 years after that, the tools got gradually better. They got maybe over-engineered. About Oracle Designer, for example, David, which that was my fault. I was calling.
Yeah, I know. I remember it being your fault.
I know, that's why you were blaming me, I suppose. Maybe we got over-engineered, it got over-complicated. Like Frank said, people jumped into all the sort of techniques as being over powerful, more powerful than they actually turned out to be, less universally useful. And it took maybe there was a long learning curve for SQL, but it succeeded. That early promise was not snuffed out for maybe 20 years, from those mid 80s to mid noughties. By then, everything was on a SQL database.
And you wouldn't want to go back to something which didn't do that for large parts of the workload still. I mean, there are other databases and there are other theories here. Graph, and I'm sure you'll touch on NoSQL as well in a minute. But fundamentally, as a business language, breaking things down into small components, talking about the relationships between them, is an intuitive way to think about information, which makes it easy.
Yeah, and what had happened in parallel in the programming world during those 20 years was that object-oriented programming became ubiquitous. People started thinking about objects and business objects, and these are not quite the same as relational tables. Well, they weren't the same, but many of them had the same names. If you looked at a domain model in a piece of code, then that would be much the same as the database model, or at least a lot of commonality between the two. And I think that was maybe where the challenge came to SQL. Why did NoSQL not exactly knock it off its perch, but it wobbled the perch for a while, didn't it? Andy, did you observe that, or were you kind of insulated that in the warehousing world?
Well, not really, because I think you talked about a couple of things. Then I think these new ways of doing things came along because you did start. People were starting to get more interested in maybe semi-structured data and a few other things. There was always limitations to what you could store without a big engineering effort in a relational database, right? A lot of pre-processing and things like that. I think the main thing was probably about the scale and the flexibility. The scale in particular. At the edge, with something like a Teradata or an Artesia, you could do a lot of use cases, but it started to become very expensive and require a lot of infrastructure and hardware to be thrown at it, to the point where it probably didn't make a lot of sense when the volumes of data exploded. And I think that resulted in some of these alternate technologies coming along that allowed you to store and process that data probably at much lower cost. Now, the downside of that was, I think, for someone like me, it was in the relational world, and my world was structured, right? And that's kind of what I did. I probably didn't get the use cases at first for some of these things. I was like going, I can do all that over here. And you had to kind of look at it along those lines and say, why can't they do it in here? Well, obviously, a Teradata and a Artesia box would cost you too much money. That would be a good starting point. But the other thing was, you were tied to certain ways of doing things, and given the nature of some of the data that came through, and I think it did make sense. But it took me a while to get used to it because, again, the type of organizations I was working with, their world was structured. They didn't really have a lot of these new and interesting data feeds and weblogs and things coming in their direction quite yet. As soon as that started coming along, the limitations of being completely structured obviously became blatantly clear to us.
I remember being introduced to NoSQL and people talking about, it was all about the unstructured data. And they say, what sort of unstructured data? Oh, this IoT stuff. He said, oh, hang on, it all comes out of a box. It's exactly structured. You can't get anything that's non-structured off a weblog. It's exactly structured. It's just not a structure you're used to dealing with, and not in the volumes and the arrival rates that you deal with that. And I remember that, seeing that side of it, the same as you, Andy, where NoSQL was banging at the door because of I thought it was more about velocity and volume,
So there's an
interesting operational side is different. David?
Yeah, I think one of the interesting things is why innovation occurs in the database market. And I look at three big groups in this. Telcos. So a lot of my early part of my career was heavily involved in the growth in telcos, whether that's Teradata or even with Oracle, where we were storing CDRs, and 3G networks coming in. Sounds radical, but they had more data than we'd ever seen before in databases. And we struggled with Oracle and things. That caused one level of innovation with Teradatas, with Natizas, with all those sorts of things. Then there's payments, which has taken off over the last few years. That's where banking, and as you know, I ran an enterprise data platform for a payments provider. That's caused another innovation. And the third group is web scale. It's the things, the social media, the sort of web, the Twitters, the Facebooks, which is part of the Yugabyte heritage and things like that. And these ones are what drive these different innovations, but they drive innovation for a period of time. They drive innovation to solve the problem immediately in front of us. But then as we learn how to use those techniques, we start to drive those things back towards the SQL database, interesting enough. So you sort of expand out to do this because you can. And then after you've normalized that or understood that and it's become operational, you then try to bring those features back into SQL databases.
Yeah, I think there's another angle. But Frank, did you feel when you were in your Oracle operational systems, where did you see NoSQL coming from? Was it?
I think I've seen from two origins. One was the need to scale, and the need not to think about the schema first, because we have a schema, but we can ingest data and do something with the data later. But I've seen that also from developers, just because they were using objects in Java, and they didn't want to map that themselves to SQL. And then they were using object relational mapping. And I think this is where it made sense for them to manipulate directly objects with the database rather than going through this mapping. But of course, the vision is completely different, because then you do not interact with a database, you interact with one point of view from the data.
Yeah, I think that was the other angle that I remember, was simplicity. Just getting started. It seemed easier. Just check the data object straight. Just use it. You're using the database as a bucket, place to store the data when you're not actually doing something with it. So what you're talking about now is here was SQL. It was ruling the roost. It was where all operational analytic big databases in big organizations around the world were SQL. And then suddenly we've got NoSQL databases, or less schema defined or differently defined databases, if you're offering advantages, offering innovation, David, in both of those worlds. So why didn't SQL roll over and die? How did SQL manage to survive that quite legitimate assault?
I think people want to come back to the things they understand. There's a huge pool of skills and resources out there, and they understand SQL. They understand, it's intuitively obvious. As I said before, select star from an object and join it to these things is where people think about it. So as this innovation has gone on. Some of these interfaces are very complex for some of these NoSQL ones. I mean, fine if you're a developer and dealing with certain object stores, but for a lot of people, it doesn't have that accessibility that SQL has. And that's why, it's been no surprise to me that open source databases like Postgres have been able to, they're popular, they're easy to have to hand, and people want to grow those things. But they also want them at scale. So this is where this sort of next innovation has come from.
One of the questions that we've had in from one of the audience was talking about where you picked up on when we were talking about denormalization and further, I think, by the talk about using, the data bucket, is if you've got denormalization, you've got duplication of data, you've got it in multiple JSON objects, for example, how do you enforce consistency between those? Now, for me, that was one of the enduring virtues of SQL was, or at least the SQL databases, was, constraints, indexes.
And that's going to come back as well, because as we move to more data regulation, more data governance, actually having control over these things, actually having some structure over the data and controls over it.
And transparency of it.
Yeah, the transparency, you can only put it here, it can only be, it can't be duplicated elsewhere, is going to, the world's going to push more and more into these features as well in the future. Yeah,
because when we got to, sorry, go on, Frank.
Yeah, I was mentioning that the difference is that what the database doesn't do, you have to do it in the code. So with no SQL database in your application, you have not only your business logic, you need also to think about data consistency, concurrent access. Where with a SQL database, you can really code as if you are alone on the database and the database will take care of it. So it's easier to manipulate objects with no SQL databases, but you also have more to do in your code to maintain all that.
So you mean by having the database at the back and putting the rules of the data in the database in terms of constraints in uniqueness and foreign key constraints and others, you can then, it makes it support a team better, that everybody's doing their own thing, but nobody can screw up anybody else's data.
Yeah, actually, if you run with a serializable isolation level, you act as if you are alone on the database, and the database will tell you if there are some conflicts. You don't have to check it yourself.
Right, much less.
I think a lot of it is driven by the use case and the user as well. I mean, I think Frank mentioned it, user preference. Some people like coding, right? And some people like SQL. There's a slightly different mindset for where the skill is.
Yeah.
But the use case is massive, right? Even in the analytics space, a lot of people, the vast majority of your users who, just want answers to questions, they like that very, very structured world. But people who are more into data discovery, they might like the idea of schema on read. I've become a massive fan of that right now. It's technically possible with some of the tech we've got out there. So that just gives people who are doing discovery, we don't really know what we're going to do with that data yet. Let's get all the operational data into a big bucket, as you said, and let's be able to do effective discovery on it very quickly. The follow-on to that, which is what David, I think, was saying, is that's then going to introduce a whole bunch of guardrails that are going to be needed to make sure that people are doing the right thing with the right types of data.
So we're a lot of old SQL heads, and we kind of see this from the data point of view. And Andy, I think you're right to point out that some people just like to code. And I'm reading loads of comments that we're getting from people watching, and they're all saying, yeah, but what NoSQL did, the problem NoSQL solved was nothing to do with programming, nothing to do with the schema, nothing to do with the data. It was scalability, wasn't it? It was horizontal scalability. That was the kind of tying tighter and tighter.
I think it's a completely valid comment, right? Because again, that's what I was saying. Could you do some of this on a Teradata or a TV? You could if you had enough money. Yeah, or that type of thing, and being able to, especially the early days of cloud coming along, that was another example. People wanted to stand things up and knock them down really, really quickly. All the setup and the structure of some of the original SQL data, relational databases and technologies and that just doesn't allow you to do that. So, I think it's a fair comment.
Yeah, I know. I think it's massively. I'm going to come back to that comment because there's a lovely little discussion going on in the comments from some of the watchers, and I want to come back to it because I've got some other points in it. But I just want to say that for me, this was why NoSQL succeeded as well as it has done. Was not just ease of use, yeah, and variability of escaping the rigid schema. It's about this scale out. And somebody in this thread said, why can't we have a database that scales out horizontally, but it's still got SQL in it? We can. It's called NewSQL. I say, well, we'll come back to whether it's called NewSQL or something else. But I want to explore that. Why did all the NoSQL databases throw away the, if you like, the consistency baby with the SQL bathwater? They did. Why didn't they do that from day one?
I think some of it was, again, I'll sound like I'm coming back to the same topic all the time, but again, I think my early days, banking, telco, very structured, very, things needed to join up and add up and things like that. You're doing different use cases with some of the higher volumes of data. Your tolerance for not everything not being 100% accurate was probably there because you're looking for patterns in data and things like that. So it's almost like we'll take that compromise and we'll try. And again, a lot of the data profiling people were doing, I think, was to try and understand the demographics of the data. Then they knew if they were just getting a completely, incorrect steer. But that's one of the things that I felt where it was obvious it got traction, but you couldn't use something that didn't have that reliability and that guarantee of a consistent view if you're running an accounting system or and things like that.
That's very much what I think where it evolved from. SQL databases didn't just disappear; they carried on serving all of those critical consistency transaction use cases. What happened though was innovation in that web scale stuff, which said this is what we're using it for, and you're creating a new technology. It takes time to create a new technology and get there. So what can we shortcut? What do we need? And the requirement wasn't there for 100% consistency, those sorts of things. But as people have understood those, that comes to Di's point about NewSQL. Now people have realized they want to drive those two things back together. So this is what I was trying to say earlier about branching off to innovate and then coming back into the SQL fold over time. Is the innovation was we need to have these things. We need horizontal scalability. We need elasticity. We need web scale type stuff, geo placement, all these things. And now people have said, well, we understood those, but we still want that transactional consistency and things. And that's where the NewSQL comes in. That's how do we drive it back to that point? How do we get those features back into the core ecosystem that we deal with every day?
Yeah. So there are, there's plenty of use cases where you don't rely on that consistency and one of the early big data use cases, Andy, I remember I talked about it for IoT, where you had streaming data. Well, actually, because this event from this sensor at this place in the world at this time on the clock can't happen again. There isn't an inconsistent, it's arrived, it's a meter reading on the electric meter in my house at 4:33 p.m. on Wednesday, the 20th of July. Well, bang, that's gone. It's captured. And by the way, if it got lost somewhere, it really doesn't matter because there'll be another one along in 10 minutes. So I think, there are other use cases, plenty of more generally business use cases where you can do that. But for me, and I think we're all agreed on this, is this point where, oh, wait a minute, we have compromised here. We've thrown away consistency in order to get scale. Scale was important, not just scale; it's resilience, isn't it, David? You're always beating me on the head for forgetting to talk about resilience and the importance of that. Do you want to dive into why? Because your payments background certainly makes that.
I mean, in terms of resilience, as we've come to expect everything always on, nobody expects to go to a Google website and see, for search and say, sorry, please come back in 4 hours. We may have finished our upgrade. the paradigm has changed, and the paradigm is advancing all the time. So, it might have been a minute's downtime, but now it's a second. When you touch contactless, and as you say, I was at a payments organization, and they absolutely relied on being available all the time for these things and authorizing. In fact, payment systems build in multiple levels of redundancy, so they do the authorization and then they have more time to do the settlement to give that user experience. So we are looking for that very high resilient type system at scale. And also, we're starting to realize now that cost is important, and also the environment, cost in that environment. So we want to scale these things up to meet demand and scale them back down. So this resilience has to come tied with elastic scalability, which we saw, which we've latched onto when we started seeing what the NoSQL databases could do. But what we want to do is transition that back into the relational world that we're familiar with,
but also because in a world of somewhere like payments, it's in the crosshairs of scale, resilience, and consistency.
Yeah, absolutely.
Yeah, and that was why there was a space for NewSQL. My own view is that the early players in that space didn't really quite deliver, and where they had scalability, what they really meant was a cluster in the same failure, effectively in the same failure zone, in the same data center. So you had scale, and you had resilience in the sense if any one node goes, you're okay. But if you lose power to the data center, you're not resilient for that. So you don't have true scalability. That's kind of, I characterize NewSQL as coming back to crack this problem of the distributed transaction, but only distributed over clusters of machines in the same area, the same what would in cloud terms be a failure zone. Is that a reasonable characterization, Frank?
Yeah, I think you are talking about Oracle RAC or something because they share the storage. But what has also changed is the infrastructure with the clouds. Because when I started with databases, 1 millisecond was the time to go to a disk, and today 1 millisecond is the time to go to another data center far enough to not fail at the same time. So probably what we do today is possible because the infrastructure is there also. When NoSQL databases started, I think it was more difficult to guarantee acid properties over network between data centers.
I think the scale and the compute power that a cloud solution gives you allows you, as someone who's offering a service, to do some very complicated things that on their own would have been difficult to do especially when you were just on-prem. So again, to me, there's two things: the architecture of how you're laying the solution down to take advantage of what the cloud's giving you, which is flex and scale, is massively important. And then the second thing is making sure you are looking at your architecture and not just assuming you can drag and drop an on-prem architecture into the cloud and it'll suddenly magically run faster. You made some good comments, somebody else is looking after it, they're keeping it up to date, they'll fix it when it's broken. You don't have to worry about that, but that's just part of the challenge, really, when you're trying to address some of these, ever-increasing demands. As David said, I think the users want the data as quickly as possible. They don't want to be hanging around. They don't want to wait for things and things like that. They just want to act on it as quickly as possible.
And there are other dimensions. I mean, it's not just failure. We often concentrate a lot in these sorts of things on failure. But it's the day-to-day aspects of this. It's patching servers. It's doing rolling upgrades. When you start talking about distributed SQL, NewSQL systems, the ability to roll those servers over, take them out, patch them, put them back in while other servers carry on serving, means that all of those add into that high availability. So it's not. We focus a lot because it's the easy thing. What happens if I lose a data center? But actually, day to day, there's a lot of cost just in the operational side of running these things, keeping them up to date and everything else, especially as regulators get more tight on these sorts of things for security. So it all comes together, this pressing need to have those cloud native features, the scalability, the resilience, the high uptime, but also the familiarity with these things. So there's so many drivers that are coming in all at the same time to make this the right time to start thinking about it.
Yeah, and and a couple of you mentioned, the move to the cloud computing as being sort of like an opportunity, but it was also a driver in the sense that there were things that you had to accommodate cloud computing, because I remember it was the applications jumped into the cloud first, and the database stayed in the data center because it was the monolithic database, because you couldn't. It was that, if you like, that distributing the database was a driver, because you can't have, as you said, David, a cloud native database. It's a kind of funny phrase, that, but what you mean by that is this thing about scalable, resilient, and distributed over more than one failure zone.
Yeah, I mean, if you think about this in three parts, being in the cloud, virtualization, Kubernetes actually allowed us to modernize the infrastructure, and that gave us a toolkit to modernize the infrastructure. We then pushed heavily, as you said, into applications, and what we've done is got all this modern stuff then going down to a single point of failure in a monolithic database. This just doesn't make any sense. If you've gone through all that cost and effort, you're not going to get the benefit unless you get what I described as a cloud native database underneath that, with the characteristics which allow you to support it.
So if I back to my history story of old SQL, and it gradually took over the world, and it got threatened by NoSQL, both because the programmers found it easier, the OO programmers found it easier, and also because the big data people found it limiting. But it stayed at the backbone of a lot of business systems until it was dragged into the cloud. And that's what I would call the mid-teens revolution of NewSQL, this idea of the distributed transaction, albeit distributed on clusters. And then the next jump, which is the kind of the generation of databases, probably Google Spanner takes a lot of credit for that being in early, but where Yugabyte, the space where Yugabyte are now, which is, oh wow, yes, we can have the scalability and the resilience of the NoSQL databases, and we can have the consistency and distribution, but consistency, and then from the SQL world that we know, that we certainly know and love. How did we do that? Because there's, as one of the questions in the comments says, there's this thing called the CAP theorem. How did you do that? And I know the answer to this, but David, I want to hear your answer, because I like it, because it always makes me laugh.
Oh, I'm going to get the wrong answers he wants there.
No, I'll get.
So CAP theorem is important, and in terms of what, I don't know which answer you want now with these things we talked about.
Oh, I don't care. Give the answer that the world wants, David, the proper one.
So first of all, credit to, before I dive into this, I think Google did a lot of work with Google Spanner to get the underlying ideas together. There's a lot of great paper about Spanner and everything else. But what they lost was this idea of what the interface should be, which is the Postgres layer, which is familiar to people. I think what you end up with when you start looking at CAP theorem is we need to have an AP database to be transactionally consistent. So it has to be available, CP database to be transactionally consistent. But availability isn't a binary thing. It isn't on or off. Because of those sorts of things that you have with those servers, you can move the slider across, so you can make it increasingly available. Now, that doesn't give you 100%, but if you can move it to 99.9, 99.999 across on availability, then we're not breaking CAP theorem, because we are still a CP database. But we can do enough with all of the things that you can do to get that to very close to where you want to have it with these things. I'll stop.
Yeah, right. I remember another of my, from many memories and many long is when somebody from a database company to a big a NoSQL audience said, oh, they could do distributed transactions, and somebody in the audience tweeted, oh wow, they've disproved CAP, which was a sarcastic tweet, and the salesperson who was at this meetup with the presenter from the database cabinet retweeted this as though no. And I think I always think that, Dave, he should have had you there to explain to him before he hit that go button.
Yeah, I think it is a common question. I think, yeah.
And I think it's a legitimate question to ask.
It is. And yeah, even I just said the wrong initials when I started with AP for all the wrong reasons. And I'm grateful for Frank not beating me up about it straight away. I'm sure he'll have a go at me afterwards. But yeah, it's getting to these things. It's understanding what's important. And we talked about why NoSQL evolved like it did. And we said, yeah, for those sort of initial web scale, you could sacrifice these things. As we move towards this highly available CAP theorem compliant database, that consistency is important. It's vital for banking transactions. I'm not happy to give people money without them taking whatever back on the other side of the ledger. But these things have to come, we have to edge closer. We're innovating and we'll keep on innovating. Yeah, I'm sure that the database is now what we call NewSQL, will in 20 years be old SQL because we'll have more compute power, more structure, and we'll have been able to change things around. But
yeah, we've already seen that since NewSQL emerged as a concept, that it was, as Frank was talking about, it was very much about clusters or shared memory. You had scale, but you didn't, and you had some improvements in resilience. We didn't have genuine resilience in the sense that we now know it with what you would show always on applications. We're getting up to the top of the hour, and I'm almost reluctant to open another Pandora's box question, but I can't resist, because I like to ask David the CAP question. I want to ask Frank the ACID question, because that's also come up on the comments in the background, and I think you've been reading those, Frank, and I think we should address that. If you can possibly do that in the next 3 or 4 minutes, then I'd be very grateful.
Yeah, sure. I think the most important, when NoSQL databases say that they have transaction, that's true, that they have transaction. The difference is, what is a transaction? In NoSQL, your transaction touches a single object, a single document. The secondary indexes are eventually consistent. You don't join two other tables. So you have only one table, one row, or one document. And then it's easy to have ACID if you have only one object. In SQL, the difficulty with ACID is that it touches complex transactions. And even if it's only one SQL statement, an insert will maintain multiple indexes. We check foreign keys with others. So even a single statement, a single insert is already a distributed transaction. And I think this is where ACID is different, complex transactions.
That was pretty succinct stuff. I think the one bit you cut out was about levels of isolation. I think which Frank, I know you've spoken about before, that is important, that where you've got, you talked about before, like if you're accessing the database as if you're the only person on it, you can rely on isolation. You didn't call it that, but in the sense that if you're going to talk about ACID, then I think you maybe explain a bit more about what you mean by the I in that. Yeah,
basically you work with the database as if you are alone, and you see a single state from the database, and that's easier to code, but more important is that it's easier to test, because I don't think a lot of companies are testing all race conditions where different session, different user can touch the same data. If you rely on the database for it, the database was tested with that, with Jepsen test or whatever, and then you rely on it, and you just mention that you start your transaction and you end your transaction. That's the A in ACID, and then the database will guarantee that your database is either the state before or the state after, but never see an intermediate state that is not completely done.
And you're talking about the state of the database, not the state of any one record or row.
Exactly. Yeah, the whole database. You see a snapshot of the whole database. Yeah.
And that's the huge. I think that's the huge jump that we get to with multi-failure zone distributed SQL databases, not just new SQL in the sense of scale, but scale plus resilience through multiple failure zones. And that's the true cloud native. And we're about time to wrap. So I'm going to that's not exactly the end of the history, but it's the end of history for today, which is where the latest you get to in SQL databases. And I've left quite a few threads open, I'm aware, from all the comments that I'm seeing. And there's also a few ideas that are coming out of this, of things we might like to talk about more on another occasion. Andy, I'm particularly thinking about the data lineage and governance, and how things move from the operational front-end systems to the warehouses at the back, and maintain consistency, not just across one database, but across a whole organization. But that's a topic for another day. So I'm just going to thank all of you and give you any opportunity, anything else that I specifically have not dealt with that you did want to talk about, or indeed if you want to slag any of your co-panelists off as giving inadequate answers, then you can each have a little chance to do that. And Andy, you go first. If there's anything you think we missed that we should have talked about today.
No, I think so. I mean, just closing the comments, the interesting thing for me, and again, in my journey, I've changed my view on some things. Like I said, there's things I've looked at when it first comes out, I don't get it. And it's always because I didn't understand how I was going to use it. And it kind of goes around, and the technology gets better, and all of a sudden, semi-structured in the structured world makes sense because it protects you from source systems that won't tell you when they're changing things and things like that, because you can do those schema memory. So all these things, we just got to see how technology develops, how the scale and flex of the cloud is going to help us do things that we always said would be very, very difficult, but we've got that sheer volume of compute and capability behind the scenes that we can start to do these things. None of us want to be doing upgrades all weekend anymore like we always used to do back in the MPP days, like put it that way.
Yeah.
So.
Frank, anything more?
I will just mention that in the YouTube chat, there are really, really interesting comments to complete everything that we have said.
Yes, I know. I've picked up one of those. I will take offline one thread. David?
I think I think we're in an interesting period of innovation. I think this is an important stage in database development, and like everybody here, the comments are where we need to go next and carry on this conversation.
Brilliant. All right. Thank you very much, all three of you, and thank you very much to all of our attendees, watchers on the various channels that we've got running here. And see you all next time. We don't have a topic yet, but if you are interested to hear the next in the Yugabyte roundtable chats, then please drop us a line and we'll keep you informed. Thanks a lot. Bye now.
Thanks.
Thank you. Bye.